All right, well, welcome back. This is probably the third video you've watched of mine. Well, it's the third one I've made. Now, I'll be honest with you, I am actually sitting in my house right now. It's summer, so I don't know exactly, by the time you watch this, I don't know what I will have shown you in class. You might have watched this early, before we do the lesson, which is what I'm going to advise in class, hopefully, if I remember. If I don't, sorry. But this is one of these topics, in case you can't read my handwriting, which again is something that you'll struggle with all year probably. This is called piecewise functions, okay? Now, piecewise functions is it's what it sounds like. It's where you take a piece of one function and another piece of another and you graph them. But you only graph those specific pieces, okay? It's almost like you're going to take two graphs and you're going to take half of one and half of the other and you're going to piece them together to make a new graph. That's actually a pretty good way to say that. Now we've already gone over functions by now, I'm assuming. I hope so. If not, we're way behind. But we've gone over functions. So let me show you what a piecewise function looks like. It's going to look like this. It looks really complicated. You're going to have f of x, which is equal to, and the book does a much better representation, but you get this bracket thing, okay? And I'm just going to make this up. Let's say 2x and negative x plus 1. Make real easy equations, okay? Then they're going to give you this. Now I'm making this up, bear in mind, so I'm hoping this is going to work. Say greater than equal to... sorry about that. That was my phone. So, all right, back to the lesson. So let's see. X is greater than 0 and x is less than 0. Now here's something you should notice, okay? And we should have gone over this by now. But this right here, this is called, again, your domain. Okay, now we should have talked about this by now, the very first section. The domain is simply all the values that the x's are. Okay, again, just the x's. The range is the y. We won't worry about the range right now, okay? Know that this is the domain, okay? Now, let's use green. What this one is saying is that for this equation, for 2x, the only x's you can use must be greater than or equal to 0. So, 0, 1, 2, all the way to infinity, okay? And use blue. And what this one is saying is that for the second equation, the only x's you can plug into that formula must be less than 0. So, negative 1, negative 2, on and on and on. Okay, so that's how this works. All right. Again, the domain tells you what x's you can plug into the equation. Now, I'm going to kind of show you, and again, this is what the book does, but it's kind of a shorter way of doing this. Okay. Now, the first thing you have to do is you have to set up two equations, okay? You're going to solve two functions. Now, this is really easy because the functions, or at least the number you're going to use for your x, is always whatever you have right here, okay? It's always going to be whatever this, usually I call it the common number, all right? That's not a real word or a real thing. I just made it up myself, okay? So this is our common number that they have with the domain. So you're going to plug f of 0 into both of your equations. All right, the first one is going to be 2x, and the second is going to be negative x plus 1. So I know you can probably do this in your head, so let's write it out real quickly. 2 times 0 is 0, and negative 0, which is just 0. No such thing as negative 0, plus 1 is 1, okay? So here's what we did, all right? Remember, these numbers that you plug into your domain represent your x. And we've already learned this. What you get out represents your y. Okay? And what can you do when you have an x and a y? You have a point. So this one gives us the point 0, 0. This one gives us the point 0, 1. Now, these are really important points. I'll write this in gray. Put a big star. Well, that's a terrible star. Try that again. There we go. Star. Okay? These things right here, okay? Star equals, we're going to call these our starting points. Okay? Now, one thing I want to point out, and I'm looking at the time on the recording, I should be able to get through all this in one video. If not, I'll make a second one, okay? But I'm just we'll be conscious of the time here. Now, these starting points, this gives a lot of people problems, because sometimes the starting points can be the same, all right? Sometimes they're the same, and sometimes they're not the same, okay? So they can be the same and they can be not the same. In other words, we could have got this. We could have had 0, 0, and this one could have been 0, 0 also. Or they both could have been 0, 1. Or like you're seeing right here, they're two different points. Okay? There's nothing wrong with that. Both options are fine. Okay, you'll find when you do the homework, a lot of them end up being the same, but there are going to be some occasions where they're not. So, all right. Now, what you should always know is that when you have a graph, what do you do with points? You plot them. All right. So I'm going to come down here and I'm going to put a graph on. Okay. As soon as I get this to work, there it goes. All right. So here's our graph. I'm going to make a really big graph because I don't know how much I'm going to need. I'm also going to zoom out a little here, make it easier so I don't have to scroll as much. So I'm going to put my 2 starting points. Now I'm going to do this one in red, and I'll do this one in blue. Okay, just so you can have them different. All right, so that way it's easier to see. So the first equation has a starting point of 0, 0. So I'm going to put a red dot here at 0, 0. Okay, and the next one, our second function, has a point at 0, 1. So 0, 1. Now, I just realized I skipped something. Let's see if it worked. Okay, it worked out anyways. So, let me zoom in here for a second. So the next one was at 0, 1. All right, now, notice what I'm doing. I made a closed circle and an open circle. Now, we've gone over this by now, okay? Because when you graph number lines way back in chapter 1 or chapter 2, whichever one it was, we go over this, okay? We learned that whenever you have an equal sign, like you do right here, you're going to have a closed circle. Whenever you have no equal sign like you have down here in the second domain, you're going to have an open circle. So that's why my starting point for the first one, okay, was a closed circle, and this one was an open one. Okay, and I just looked at it, does it have an equal than or not an equal to sign? Okay, that's all we did. Okay, so here we go. There are 2 starting points. Now, here's where this gets really easy. Okay, and I went over this in the other video I made. All right, so you can go back and check that. I've gone over it multiple times while teaching you, so I know you've seen this a million times by now. Okay, so now, what color? Let's see, I did the top one in red. Okay, so I'm going to write this all to the side. Let me zoom out again. And let's change to red here. Okay, so my red equation here is what? F of x equals 2x. Okay, that's a bad 2. 2x. Now, you should know this already, but whenever you want to go from a point, okay, and you want to figure out, you know, where's the next point at, we always use our slope. And we know the slope is always by x. So our slope for this equation right here is going to be 2 over 1. So we have a rise of 2 and a run of 1. Okay, so that's good. Now let's find the slope for the next equation. All right, and I've got it right here in blue. I'm just going to use the equation up here. If you notice, the slope is right here, that minus sign. That minus sign just means that our slope is going to be negative 1 over 1. So we're going to go down 1 and right 1, okay? Or up 1 and left 1, depends on which way we're going. So here we've done, well, we found probably the 2 most important things. We found slope 1 and we found slope 2, okay? Very important. Because once you have a starting point, all you need is the slope and you can graph anything you want. So, all right, last thing, okay, and I'm sure I'm doing this not in the same order I taught it during the lesson to you, but that's okay. All right, we're getting to the same thing. All right, last thing you need to figure out is the direction that your line goes, okay? In other words, this one that I circled in green, okay, or put the green star by, goes in one direction, and the one that I have as a blue star goes in a different direction. One goes right, one goes left. It's always right and left, okay? That's it. One goes right, one goes left. So it's real simple. Now, watch how I do this. This is real simple. Right. I'm going to circle this one more time. Which way is this arrow pointing? That's how you figure this out. It's pointing to the right, so that means this equation goes to the right. And, I mean, you know, process of elimination, or you could just look at this one again. This one points to the left, so that one goes left. All right? So this equation is going to be graphed to the right. This equation graphs to the left. So again, I just looked at the arrows. Treat them like they're arrows pointing in directions. One points right, one points left. It's real simple. All right? So, now just so I've got everything, so I don't have to keep going back and forth for everything, I'm going to put an R by the first function and an L here just so I can see them easier. Okay? So, we need to use our slopes now. So, let's do the red line first. All right? So, the red line is going to the right. Now, my slope, which is up here, okay, is up 2 and over 1. So here's the key. Whenever you go to the right, let's see, it's right out. Whenever you go right, okay, do what the slope says, okay? Do what slope says. So when you go to the right, you do what the slope says. In other words, we're going to go up 2, and right 1. Just what it says. So I'm going to go up 1, 2, right 1, up 2, right 1, up 2, over and over again. Okay? So again, whichever equation goes to the right, whichever has the inequality up here that's pointing to the right, you do exactly what that slope says. Do exactly what it says. All right? Now let me, let's see, let's change the color here so I can keep this all color coordinated for you. And watch, I'm going to start at my starting point, and I'm going to extend the line up through my points. Oh, kind of missed, but that's all right. Close enough. All right? So there we go. There's one line. Now, let's find the next line. All right? I'm going to go ahead and change the color, so we'll deal with that later. All right. So, now here's the next part. This is what everyone makes mistakes on. I'm not going to lie to you. Everyone seems to make the same mistakes every year I teach this, okay? So, right, you do what the slope says. Whenever you have left, okay, whenever the arrow is pointing to the left, whether it's equal to or not equal to, it doesn't matter, okay? You do the opposite of the slope. Well, let's put opposite of the given slope. Okay? So do the opposite of the given slope. So let's look at our slope up here. It's negative 1 over 1. So normally what we would do is we would go down 1 and to the right 1. Okay? Now let me show you why this doesn't work first. And I've got a few minutes here. I'm going to do this in, I'll do it in green so that way it kind of sticks out. So normally the slope says we need to go down 1 and over 1, down 1 and over 1, down 1 and over 1, down 1 over 1, okay? So this is what our line would look like if I drew it, okay? Sorry for the poor quality there. So now notice this. Our lines are crossing. Both of them are going to the right. But what did I tell you, okay? Every time one must go left and one must go right. Okay, now we already proved because of the arrow up here that our top function, the 2x, must go to the right. Okay, again, must go to the right. So we know this one can't go this way. So that should be your first clue something's wrong. Okay, or say, well, I messed up here because that can't work simply because they're both going right. And again, remember, the rule is when it goes left, do the opposite of the given slope. So if we originally went down and to the right, now we want to do the opposite. Okay, we want to do the opposite, which is going to be go up and to the left. Again, notice this one thing. The top equation which went to the right, what did we do? We went to the right, okay? And the one that went to the left, we went to the left. So there are little clues here, there, you know, once you do enough of these, you'll catch on. So I'm going to go up 1 and over 1, up 1, over 1, over, up, over, and over and over again, okay? All right, and watch, we start here. And if I extend it far enough, it'll make a straight line. There we go. And there we go. So notice, we've taken two lines, the function of 2x and the function of negative x plus 1, and we've taken specific pieces of them, specifically, okay, the piece that goes to the left for the blue line and the piece that goes to the right for the red line, and we put them together to make one function. Okay? One function. So, and hence the name piecewise function. It's a function made of multiple pieces, okay? Now, last thing I'll tell you before I'm done, because I've only got about a minute left till this goes off anyways. Here's one thing you should notice. Change the color. Let me make it, I don't know, purple. Why not? All right? So, here's one thing you should notice. Let's do this. All right, just go right down the middle. Now, it doesn't matter that it's on the y-axis. That's kind of a side point right now. What you should notice, though, is that the starting points are directly above and below each other. They will always be directly above and below each other. If they're not, you messed up, okay? So, all right, I know that's a lot, and it's going to seem like a lot when I teach it to you the first time, but I went through it pretty slow. I covered everything again. So if you need more help, come see me in the mornings. See if I can meet you in the afternoon for, you know, maybe I'll have a day off or something, who knows. But yeah, so hopefully this helps with piecewise functions. It's one of the hardest things we graph all year, so don't freak out if you struggle with it, okay? All right, thanks for watching again, and hopefully these are useful.